Hi, I'm Sonny Oliver, a global product champion for surface equipment. And today I'm going to be presenting on remote monitoring and autonomous operations as it relates to our offshore cementing. For an agenda today, I'm going to give a brief overview, talk about the levels of control, a little bit about the history, and how we do remote monitoring today, as well as show a video of the experiences the GM has in remote monitoring. Then I'm going to pivot over to talk about autonomous cementing. I will talk about the expansion of Cognitus, and then we'll watch another video from Aker BP and how they've been able to use Cognitus and how it's benefited them. And then I will follow up with some validation. So as an overview, the year before last, I had the opportunity to stand up here and present on what autonomous cementing is and what it is enabling us to achieve in terms of capabilities. And so I hope by this time, you have at least heard about the automated cementing platform we now call Cognitus. I will briefly touch on what it is and the capabilities, but what we'd like to demonstrate in today's presentation is a little more insight around what it looks like from an onshore supervisor that is monitoring and performing these jobs. What is it they are focusing on, and what is it that we're truly enabling when we do this? I don't want to skip over what it is or what the value is, so if you would, please let me do a quick recap. Autonomous cementing is the unit's ability to execute a cement job with little to no human intervention. We have units today that can do this, and the journey to creating that capability has also allowed us to improve those things we're doing around remote monitoring. There are several drivers as to why we want to do this, but here are a few that I'd like to highlight. Improved operational efficiency. Our onshore supervisors will be able to support multiple rigs and across multiple basins, diversifying their experience and allowing them to navigate a multitude of scenarios. Increased quality and consistent delivery. This is our best practices being embedded into the automation so they get applied the same way on every job. And then there's an enhanced oversight. We are putting all the pertinent data to make useful real-time decisions at the onshore supervisor's console and within close proximity of our SMEs. And then there's the reduced HSE exposure. We are removing personnel either from the red zone or from the rig altogether, reducing their exposure to pressurized lines or the red zone, and overall reducing our carbon footprint of the operations. So here I would like to explain the way we have referenced our remote capabilities over the years. Level A was about having remote control of the pumps and getting our operators off the unit and put some distance between them and the high pressure pumps. And it was you, the clients, that identified the opportunity to reduce that exposure of supervisors by pulling them out of the red zone. That led to the development of our Level A kit, which took place back in the 90s. Then we have Level B, which is about having local remote control of the entire unit, getting our operators out of the equipment room altogether and into a control room on the rig. And again, it was you, the clients, that were putting more focus around creating a better, safer work environment. That, coupled with advancing technology, led to the development of our Level B kit just a few short years after the Level A. And as it sits today, a little over 50% of our fleet is kitted with a Level B system. Now, let's leap from the late 90s and early 2000s era to today, and let's talk about Cognitus. This is about having remote control of the entire unit from shore. You as the clients have continued to drive operational efficiency and pursue ways to reduce operating costs. And about 3 years ago, one client in particular, Aker BP, challenged us to deliver a fully automated cement job from shore. And this led to the development of Cognitus. And it's comprised of two components. One is the remote control piece, which is for the most part mirroring our Level B and moving it onshore. And the second component is the automation, which I will discuss in more detail later. But know this, the first fully automated remote job was performed in November of 2020. So remote monitoring. A fully remote, fully automated solution is leading edge technology for our offshore cementing equipment. But like other technologies, it will take time to adopt and is not a one-size-fits-all solution. So we don't anticipate this being the standard solution for all applications, but rather looked at case by case. There are, however, things that we have learned through the development of Cognitus in conjunction with advancements in hardware that have improved the way we can remotely monitor a job. And I think this is one of the things that will become a standard solution for a lot of operations. The controllers and the logic and the sensors we have in place today allow us to view remotely a lot more information than we could in the past that allows us to make more useful real-time decisions on a job. Now, I don't want to go into much detail because that is part of what you will hear as our GM team shares their experience in this first video.
In an offshore cementing environment, noticing an error after a job is complete doesn't bring much value. Why? Because after cement is placed, there isn't much you can change. Errors can cost an operator significant operating time and ultimately money. For this reason, it is critical that job parameters are monitored in real time, so errors can be mitigated before they cause NPT. As some of us can remember, initial offshore cementing efforts began by sending lab tests and procedures to an offshore operator for execution, then receiving feedback after the job had been performed. Luckily, over the years, industry standards and technology have evolved. Cement job data started to be transmitted and monitored in real-time centers. There were typically 4 primary variables that you had visibility to: pressure, rate, density, and volume. While these variables show job progress and can identify a problem has occurred, they are only showing the result of the problem, not the root cause. Identifying the result of the problem with no ability to intervene does nothing to mediate the problem in real time. A few years ago, Halliburton Gulf of Mexico took a deeper dive into the drivers behind our NPT. While we identified multiple areas for improvement, we discovered the largest contributor to extended NPT events was not recognizing an issue had occurred, primarily during the mixing of the operation, and more directly, the improper addition of liquid additives. To effectively address this challenge, Halliburton advanced our remote monitoring capabilities. First, increasing the data transmission to include actual mixing parameters. Then, having onshore personnel who have direct knowledge of our offshore systems and understand job design monitor these parameters in real time. The most critical piece, these individuals have a direct line of communication to the rig site. These personnel are able to intervene when needed. This service provides real-time data oversight and feedback for improved operational efficiency and ultimately reducing HSC exposure and overall risk.
Welcome to the remote monitoring room, where Halliburton onshore supervisors support our offshore team by remote monitoring jobs in the Gulf of Mexico. While this room serves as one of our remote centers, our onshore supervisors can remote into a job from just about any place that has a good internet connection and displays. The execution of a cement job can take as little as 45 minutes, but it takes days of preparation. Part of that preparation is the day before the job we have a final review. During this review is where I go over the lab test and liquid additive system lineup. I then review that lineup with the service supervisor and we confirm the set points on the CMS are entered per the design. The entire program is reviewed at this time. However, the liquid additive system is where I put my main focus, as it's one of the more challenging things for a supervisor on the rig to stay focused on while they are mixing cement. For the typical connection, our supervisor on the rig sends WITS data to a rig in the box. From there, the data is transmitted via satellite to shore, then to a secure Halliburton connection. It's from there that I open our Insight software and view the real-time data. I confirm that I am receiving all the variables that I need to monitor the job. For our more modern cementing units, such as the Advantage 1 or our upgraded Advantage units, there are more capabilities in what I can monitor. Connecting to an Advantage 1 unit does not require WITS transmission. We essentially remote into the system and are able to see what the service supervisor sees on the HMIs in the control room. This expands my visibility from shore. For example, I see set points that the supervisor has entered for the liquid additive system. I can also see his valve alignments and a host of other things that allows me to follow the job with greater visibility to what's happening on the unit. Connection to the cement unit is a straightforward task. However, the process of connecting or communicating with the service supervisor on the rig can be challenging as it varies from rig to rig. There are cases where the supervisor has access to a landline and we can communicate through Teams or phone. And then there are cases where I do not have any direct communication with the supervisor. In any case, how we communicate is predetermined before the job to ensure we have some way to intervene if necessary. There are some common variables that you will see on all real-time cement charts. This is pressure, rate, density, and volume. They can be seen on the left side of my screen with colors indicating the different variables. On the right-hand side is where I am watching the liquid additive rates and volumes. We can have anywhere from 2 to 6 different additives being injected at the same time. I am ensuring that they are being injected at the correct rate in comparison to the rate the cementer is mixing and pumping cement. The cementer has the ADC control screen in front of him, and the liquid additive control screen is off to the side in his peripheral. So while the supervisor is focused on the cement density, I am focusing on the liquid additive screen. If at any point in time a variable is out of range, an intervention will be made. One of the other things I am working on during the job is post-job reporting. Are we achieving the job metrics? A post-job is always provided, but oftentimes it can take 24 to 48 hours for reports to be generated and received by the operations and the client. With job metrics defined before the job, I work through those metrics, updating the status as the stages of the job are completed. So at the end of the job, this allows me to send out a post-job report within an hour of the job being finished. When everyone wakes up in the morning and checks their emails, there's a post-job in there waiting for them. All parties concerned will have instant notification of requirements met or not met through the predetermined critical success metrics. As an onshore service supervisor, I am the second set of eyes on the job to ensure it is executed according to plan. I can focus in on the cement rate and cement density, mixed water rates, and liquid additive rates, and can immediately intervene if the variables do not follow the plan. Recently, we had a liner job where a liquid additive pump was not injecting at the correct rate. As the onshore service supervisor, I was able to intervene and have a discussion with the rig offshore supervisor before any cement was placed downhole. The issue was corrected and the job continued with no incidents or downtime.
Our remote monitoring system is the next step in our offshore cementing evolution, allowing us to monitor wells across the world. Over the past year, the Gulf of Mexico deployed remote monitoring capabilities on over 18 rigs. To date, remote monitoring has led to 16 true interventions, ensuring each of those jobs were performed as designed, addressing issues before they become a problem, allowing Halliburton to deliver improved operational efficiency and reducing overall risk. The steps Halliburton Gulf of Mexico are taking today with remote monitoring are laying the foundation on which remote control and automation can be integrated into the future of offshore cementing.
I hope that video was able to give some insight into our remote monitoring of a cement job. And now let's talk about, or more about, remote control and automation. The Level C platform I referred to earlier is the remote control component, but it's really the automation hardware and software in conjunction with the Level C that make up the platform we now call Cognitus. It's the automation that is enabling the success of these jobs being performed from shore. Those 300 mouse clicks or valve movements that were having to take place have been reduced to less than 10 through Cognitus. Those 10 or so clicks coincide with the typical stages of a job, from pressure testing all the way to landing the plug. The platform is on the cement unit itself, so once the job parameters have been entered into the system, the cement unit has the data it needs locally to execute the job, and once the operator hits starts, or hits start job, or advance a stage, regardless of connectivity back to shore, it can proceed with that stage. Automation overcomes some of those gaps in connectivity that we will experience when remoting from shore. Listen to what Aker BP and our local operations have to say about the system.
Aker BP has for a long time looked at digitalization and automation projects, and we team up with our alliance partners to deliver an operation, a cementing operation that we can perform from shore and fully automated.
Basically, before we had an offshore control room where the operator was sitting and doing all the cement operations on the rig. Now we move the cementers into the office building, and we need to move the controls from offshore to onshore. This means increased efficiency, reduced cost, and less exposure to HSE. Now we have programmed the cement unit to do the best possible operations every time, rather than being a human interface. Same as if you have your own car, you and me drive slightly different. Now we said, this is the way you're going to drive, this is the way you're going to drive every time. So that would be one of the biggest changes.
For me as a cementer, it means that I don't have to travel offshore anymore. I don't have to take a chopper. I can walk 5 minutes from here, from home, and I can, when I'm finished, I can go home, meet my kids and family, friends, and I still do the same job as I did offshore, just from this computer. I believe this automated system makes the quality of the cement job much better, because we can pay attention to everything that is important, which is the quality of the cement, that the rates are properly, and the pressure, and we don't have to press the mouse button all the time. Before, we had to press almost 200 clicks on the mouse. Now we're trying to get it down to 5 clicks. This does it automatically, and the quality of the job will be better.
Well, I can tell you one thing, we are the first one in the world to perform a job from shore fully automated, and that's a heck of an achievement for the Alliance.
So, a few things about the Cognitus. We have been running it with Aker BP for almost 2 years and completed over 80 jobs since that time. Some of these jobs have been performed over a fiber connection, but more have been over a satellite connection. And in some cases, the job was not controlled from shore and Cognitus was utilized at the control room on the rig. We have 2 cementing units running this platform today, one on a semi-sub and another on a jackup, with future installations being evaluated. What's next? Well, we've spent some time this year scoping and field trialing some sensors to be able to monitor some of the critical components that would typically bring a technician to the rig for an inspection. Once we package these sensors together and install on a unit, we think it can take what may be 4 to 6 trips to the rig per year down to 2. The validation of Cognitus has been a rewarding process to be a part of. We have seen some Halliburton and most likely industry first around autonomous cementing. A lot of this made possible by the vision that Aker BP has around an unmanned rig and the industry's desire to digitize the oil field. These efforts in automation of our cementing units and expanding the remote monitoring capabilities are part of our technology roadmap for automated operations. It ties directly into our vision of delivering through intelligent systems. This is the future of how we will execute.